Hello, I am Dr. T. Biram Singh, Assistant Professor from ENT Department, Janims. Today we are going to discuss about the anatomy of the inner ear. The inner ear anatomy is very important. The discussion here will be mainly for the undergraduate. So, as you know, by the time this discussion is over, you have to know a little bit about the inner ear, the mechanisms of the embryological developments, the bony labyrinth and membranous labyrinth, the different parts, a little bit of the uh, sensory organs, then perilymph and endolymph, and a little bit of the clinical applications. You know that the inner ear is lodged in one of these parts of the temporal bone. As you know, the temporal bone has got a squamous part, which is this portion. This is the squamous part. Then you have the tympanic part of the bone and the mastoid part. Then you have the styloid process and the petrous part of temporal bone, which is inside the, you cannot see from this view. So this is the petrous part, and you can see cochlea here. This is the cochlea. You have the three semicircular canals. This is the superior, this is the posterior, and this is the lateral. Then you have vestibule. So you have vestibule here. You can see the three semicircular canals opening here. Then you have the internal auditory meatus. So you have the cochlear nerve coming here. The superior vestibular nerve will be coming here. The inferior vestibular nerve will be supplying the posterior end of the your posterior semicircular canal, or the ampullary end of the posterior semicircular canal, and the saccule. So you have got one is superior vestibular nerve, then you have the inferior vestibular nerve, cochlear nerve, and above the cochlear nerve you'll be having the facial nerve running like this on top of the cochlear nerve. This is the middle ear. This is the middle ear, and the stapes, you can see the two cruras of the stapes, and the vestibule is on the lateral side. It is filled by the footplate of the stapes and surrounded by the annular ligament. We'll be discussing in detail about this later on. So you have the external ear extending from the pinna till the tympanic membrane. Then you have the middle ear from the tympanic membrane till the footplate of the stapes. And the inner ear you have got the different types of the, say different parts, as you know, the semicircular canal, then the vestibule, and the cochlea. So this vestibule along with the semicircular canal will be taking care of your balance system, and this cochlea will be mainly concerned with the hearing. So these are the basic functions of the ear. Some slides are going to be repeated, and mostly so that you can read even if you missed while we are discussing. So basically you have the inner ear. You can divide it into bony labyrinth and the membranous labyrinth. See, the bony labyrinth is the outer cell, and inside this bony labyrinth you have the, say, membranous labyrinth. So membranous labyrinth is, being covered by this bony labyrinth, and the bony labyrinth, between the bony labyrinth and the membranous labyrinth you have the perilymph, and within the membranous labyrinth you have the endolymph. I think this concept is very clear. Now this bony labyrinth, you have bony cochlea, the three semicircular canals, the vestibule, and the two things that which we didn't mention in the previous slides, the vestibular aqueduct and the cochlear aqueduct. The vestibular aqueduct, then the three semicircular canals, they open into the vestibule. The cochlear aqueduct also opens, but it is little bit on the lower part of the your round window. You have this is the bony labyrinth. You can see this bony labyrinth. You have the cochlea here, then you have the vestibule here, then you have the lateral semicircular canal, superior semicircular canal, and posterior semicircular canal. Now, little bit in detail, the semicircular canals, which are 3 in numbers, they will have the ampullated end. This is the ampullated end. This is the anterior, and this is posterior. So this is the ampullated end of the superior semicircular canal, and this is the non-ampullated end. This is the posterior semicircular canal, and this is the ampullated end. Now the two non-ampullated ends of the superior and posterior, they join together, and this structure is known as the crus commune. And this is the lateral semicircular canal, this is the ampullated end, and this is the non-ampullated end. Why this ampullated ends? In the ampullated ends, this is important because they contain the cristae ampullaris or crista ampullaris, and the crista ampullaris is the sensory neuroepitheliums are all contained in this area. The cochlea, this is the cochlea, this is the vestibule, this is the area for your round window, oval window. So the oval window will be filled by the annular ligament along with the footplate of the stapes. The cochlea, you will learn later on that it has got 3 parts. One is the scala tympani, then scala media, and the scala vestibuli. So this scala vestibuli will open into the, it will be connected, scala vestibuli will be connected with the scala tympani at the apex, and that apex is known as the helicotrema. The scala tympani will be sealed by the secondary tympanic membrane or the round window membrane. I think the concept is clear now. Now inside this bony labyrinth, you have the membranous labyrinth. So the membranous labyrinth, the same counterparts you will have. This is the membranous semicircular canals, this is superior, this is the posterior, this is the crus commune, this is the lateral semicircular canal. Then inside the vestibule, in the posterior aspect, you will have the utricle. So the utricle will be receiving the 5 openings. Why not 6? Because the 2 semicircular canals, that is superior and posterior, will join together to form the crus commune, so there will be only 5 openings in the utricle. So the utricle will receive all these openings. Now the utricle and saccule will be again connected by the utriculo-saccular duct. Then from the utricle, the one duct will be, there will be a communication, another duct will come from the utricle and another one from the saccule. These two will join together to form this endolymphatic duct. Now this endolymphatic duct will be going towards the posterior cranial fossa, and this is, it ends as a endolymphatic sac, and this is lodged between the 2 dural sheaths in the posterior cranial fossa. Now when we drill the mastoid, then we try to find this endolymphatic sac below the Donaldson's line. Donaldson, I think this is a little bit higher for, say, Donaldson. These are for postgraduates, so we'll not go in detail about those things. This is the saccule. You can see the different nerves coming. This is the superior vestibular nerve supplying the lateral semicircular canal. Then this is the lateral semicircular canal, and this is the superior semicircular canal and utricle. The inferior vestibular nerve supplies the saccule, and the one branch, this is known as the branch which is going to the posterior end of the, or the ampullated end of the posterior semicircular canal. This is known as a singular nerve. It is a branch of your inferior vestibular nerve. So when you say vestibular nerve, it has 2 branches, that is superior vestibular nerve and the inferior vestibular nerve. The inferior vestibular nerve has got one branch supplying the saccule and the another branch supplying the ampullary end of your posterior semicircular canal. And this is the cochlea, and cochlea, this is you are having cochlear nerve here, and this cochlear nerve is nothing but the axons of the bipolar cells in the spiral ganglion. So these spiral ganglions are there in the Rosenthal's canal in the osseous spiral lamina that we will discuss later on. So they have the bipolar cells. So the dendrites of the bipolar cells will be supplying the hair cells of the cochlea, and your axons will continue as your cochlear nerve. Then they will relay in the cochlear nuclei, or say it has got two cochlear nuclei. One is the ventral cochlear nuclei and dorsal cochlear nuclei in the brainstem, that is in the medulla. So some of these points will be again repeated, and I think you can read the slides for better understanding if you missed while I am speaking. Now, before coming to the proper anatomy, we'll discuss about the embryology. The embryology is important because we have many patients with the congenital sensorineural hearing loss, and the congenital sensorineural hearing loss is very important because if a child cannot hear, then he cannot speak. So such child will become deaf, and they will be mute also. It is known as a deaf mutism. And diagnosing such children with who are congenitally deaf or profoundly deaf before at least 2 years of age is very important. And many of these patients, they have congenital developmental anomalies. So understanding this anatomy is very important. And if there is no cochlea, or there is a cochlear aplasia, or if there is a labyrinthine aplasia, aplasia means say labyrinth is not formed at all, and the cochlea is not formed at all. So in such patients, cochlear implant surgeries are contraindicated. So we have to understand the different developmental anomalies, and in order to understand that, we have to know the development of the inner ear. So we can divide it into membranous development of the membranous labyrinth, bony labyrinth, and the neurovascular bundles. So the membranous labyrinth, as you know, it starts as an otic placode. Say this is the neural tube, and in the neural tube you have the ectodermal thickening. So it starts as a small, slight thickening in the ectoderm. Then what it happens is there is a depression created. This is known as the otic pit, and again they fuse together. The ectodermal margins will fuse together, and it will form the otocyst. This otocyst will give rise to otic vesicle, and from the otic vesicles 3 folds will develop. One will be forming your endolymphatic duct, the one will be forming your semicircular canals along with the utricle. Now remember this, saccule and the cochlea are from same fold, so they are developmentally they are from the same fold. So they might be having the the same vascular supply. So you have the saccule, you have the cochlea from one fold, then you have the utricle and semicircular canals from the other fold, and you have the endolymphatic sac and endolymphatic duct from the another fold. So 3 folds. Now development of the cochlea or the cochlear duct, this is membranous labyrinth. So the cochlear duct is the one or the membranous counterpart of the bony cochlea. So you have the cochlear duct, and this cochlear duct, this is nothing but, when you study later on, this is the scala media. This is the one which is forming the scala media. So endolymph will be inside this scala media. This is your cochlear duct. Now the cochlear duct formation starts by the 6th week, and they are totally completed by the 25th week. So a child can start hearing by the 25th week. Then you have the semicircular canals. Now the semicircular canals, they start as a disc-like outpouchings, and then within these discs, the center portions, this will get compressed, and when they get compressed, only this circle will remain. And remember, semicircular canals, they form around 2/3. They are not complete canals. They form around 2/3. It's more than half. So 2/3 of the circle. So the formation of the semicircular canals, the first say the superior semicircular canals are the first to form, then the posterior semicircular canals, then the lateral semicircular canal. So the lateral semicircular canal are the last, say last to complete, and the developmental anomalies are much more common in the lateral semicircular canals. Then you have the endolymphatic duct. Endolymphatic duct and the sac, their formation, they start earliest, but they are the last to complete. And often when we are planning patients for the cochlear implant surgeries, we come across a term known as the Lars vestibular aqueduct syndrome, in which the size of the vestibular aqueduct is the one, is the bony part or bony counterpart. So inside the vestibular aqueduct, you have the endolymphatic duct, and the endolymphatic sac will be in the posterior canal fossa. So vestibular aqueduct, when I say vestibular aqueduct, remember vestibular aqueduct houses your endolymphatic duct. So if the endolymphatic duct or vestibular aqueduct size is enlarged in the CT scan more than, say 1.5 millimeter, then we diagnose it as a Lars vestibular aqueduct syndrome. So any patients with the Lars vestibular aqueduct syndrome, they will have more chances of, perilimb gushers when we do the cochlear implant, or when we do aesthesiotomy. That is any procedures which involve the inner ear, there is a chances of perilimb gushers.